So in our Options tab, we take a look to see how each of the different pieces fit together and what some of the options are for our forecast. Now, if we hover over our forecast right now, we can see that we have a forecast quality of 62, and we can see that we have a prediction interval of plus or minus approximately 11 million. Let's right-click, go to Forecast, Forecast Options, and we're going to select, instead of automatic, we're going to select the 3-month forecast. So we click exactly, change it to months, and increase that to 3 months. Click OK. Now when we hover over, we see that we have a forecast quality of 62, but our prediction interval is plus or minus 9 million. So it has decreased the prediction interval, which actually indicates that it is a less accurate forecast. The precision increases, but the accuracy has decreased. Let's right-click again, Forecast, Forecast Options, and this time we're going to aggregate by months while ignoring the last month, as we have indicated here. Check the box that says fill in missing values with zeros. Now the question asks, why are we doing that and what is the advantage? So let's go over that for just a moment. The reason why we have it aggregate by months and ignore the last month is to take out basically what's called noise. As your data, the Holt-Winter model that this is built upon has at the end of it this exponential trend, or this error term that will allow you to understand how each one of your pieces fit together. The error term is the unknown. It is the part that we can't quite figure out yet. And so by ignoring that last month, we reduce that error, that white noise. It allows us to quickly understand the model, but it also decreases the precision. We have taken out part of the data. We don't understand what's going on there, so we take it out and just concentrate on the other, but we still understand that the part to the side we have to think about. So put a little more precisely, by taking out that last month, we eliminate unknowns at the sacrifice of a more accurate model. So we increase precision, decrease accuracy by doing that. Let's click OK. Now, the next thing we're going to do is this idea of seasonal and trend analysis. The seasonal trend is, as you see, this cyclical pattern where it goes up in the third quarter, down in the first, back up and down as we go across each piece. So it's the cyclical trend that you see in the model, right? The cyclical pattern that you see in the model. The overall trend is how does it increase from the beginning to the end. So if we were to draw a straight line from here to there, then we would see what our overall trend is. We're going to add that in, and then we'll talk about the difference between additive and multiplicative. All right? Right-click, Forecast, Forecast Options. We're going to leave everything else as it is. Then we're going to come here, and where it says Custom Model, we're going to make both of them additive. We click OK. Now when we hover over, we see we've increased our forecast quality from 62 to 66, and we have slightly increased our prediction interval. So by making it additive, in other words, we're asking it to go back and not only look at the cyclical pattern, but also the overall trend, then we have a better forecast quality. In other words, it's about 66% accurate, which given the size of the store is actually pretty good. Okay? All right, so now let's come back and we'll talk about what additive and multiplicative actually are. The reason why we look at that is if we forecast options, we can see that we have an additive for the trend in season. The trend being the overall pattern, the season being the cyclical pattern. So what we're doing with that is we're simply taking each of the different pieces. In the additive model, we take the seasonality, that cyclical pattern, plus the overall trend, plus any business cycles that are built in, and then the residual that's left over. And this is usually the default in most econometric models. For instance, GDP is a function of consumer spending, business spending or investment, government spending, and then net imports and exports. So we have a very simple model for a very complex phenomenon. We use this usually when we are thinking about things that can be linear. So for instance, we're going to add 300 students next year, or I am going to increase my sales by $100,000. We can solve that problem using a straight linear formula, straight line. When it's multiplicative, it becomes more complex. And usually this is when the components are relying on one another. Next year's wheat harvest depends on how much we plant today. The amount of beer that we can brew depends on the hops harvest, and hops then are depending on what we did the year before. The amount of money that we have in our savings account is a function of a percentage of our income. If our income goes up and that percentage stays the same, then it becomes a linear trend. But if our income goes up and therefore we increase the percentage that we save, then we end up with an exponential trend, right? So things that we model with this are also like the compound annual growth rate. So the CAGR, if we say we're going to increase sales by 20%, then the compound annual growth rate is 20%. So let's just keep the math simple. And if the first year we have $100 in sales, then next year we have 120. But the second year is not 140, rather it's 120 plus 20%, so we end up with 144%, and so on and so forth. And we solve this by taking the log of each side. So to see how all of this works, let's go back. We'll right-click, forecast options. Let's put it back to automatic. Let's make this automatic as well, and leave it aggregated by months. We'll now right-click the blue line. We will add a trend line. Notice that Tableau gives us a trend line for both the actual and the forecast. And so the actual, because it has this seasonality built in, is a little bit less quality, or excuse me, a little bit less accurate, because the R-squared is 0.48. So the data fit the model only 48% of the time. With our forecast, because we built the model and then added the data, rather than taking the data to build the model, obviously it's going to be more accurate. So if we have taken the line to put the data in and then added seasonality and so on and so forth, then we have a much higher R-squared at 86%, right? Okay. So let's go right-click, forecast options. Let's take a look at again some of the options. Let's go to exactly, and we will do 3 months, right? And for our forecast model, let's make it a custom model, both additive, and click OK. So now we can see that we have a much different picture. The R squared for the actual is still 0.48, so that didn't change. But here, because we only have 3 data points to draw on, we can see that the R squared has dropped from 88% down to 72%, or 0.72. That means that the data fit the model only 72% of the time, and it is a much less accurate model. Also, notice that our p-value here is 0.35. That indicates that the model that we have is not a very good model for predicting our future sales. Of course, we expected that because we dropped the number of seasons or the number of points that we are actually using to plot. So let's reset that by right-clicking, Forecast, Forecast Options. We'll take it back to Automatic and let Tableau figure it out. We'll take it back to Automatic here and again let Tableau figure this out. And we can see that we have, again, a much more robust model. So now we want to take and add a few more pieces. We already have the trend line, and we did that. So now we're going to drag the box and whisker plot to get a 5-number summary. Okay, so we go up to Analytics. Okay, and let's take the box plot. We're going to drag that over here. And this gives us that 5-number summary that we've talked about before. In Excel, we had to calculate this and then try to plot it on our own. Here, we simply drag the box plot in and we can see what the numbers are. So the lower whisker, 0. And this is a little bit funky because we didn't have the actual shipping cost in January here, but then we can add the other things in as well. So this is our maximum, minimum, median, Q3, and Q1. Okay. Okay. All right, so now that we have that in there, we can see what our 5-number summary is. Right? And to make my video look better, I'm simply going to undo that. And so now I want to take a look and see what are some other forecasting models that we can use. We do that by right-click, Forecast, Describe Forecast. And what we have here is the accuracy of our model. What we want to end up with, this is the created forecast model, so this is our summary. So our model actually fits quite well. The initial shipping cost has a plus or minus a precision number of about 8.4 million. But one of the problems we're having over here is that this seasonally adjusted low is negative. Well, we know we're not going to have negative shipping cost, right? That's someone else paying us to ship the product to them, and that's just not going to happen. Let's take a look at our model, and let's go over some of these quality metrics for just a moment. So this one is RMSE. This stands for the root mean squared error. You take the error, square it, take the average or mean, and then take the square root to get rid of that to give this forecast model. The next one is the MAE, mean absolute error. And again, all we're doing here is we're taking the error, taking the absolute value of it, and then we take the mean. MASE stands for the mean absolute standard error. So we've standardized this and we use the z-score to figure that out. And then MAPE stands for mean absolute percentage error. So our error has 9.2% built in. Okay. And finally we have AIC. AIC stands for absolute indicator, forgot what the C is. Let me look that up. I'll get back to you on that. All right. The point of all of this is that what we want is a lower number. The lower the number, the better. The lower the number, the better. Let me say that one more time. Jot it down in your notes. When you look at the quality metrics, no matter which metric you're looking at, you want a lower number. Okay? So let's go back to our summary. Take a look, right? We're going to check the box down here that says values as percentages. And again, think about the seasonally adjusted low. There's no way that we can have a negative percentage shipping cost. In other words, our percentages here are not going to dip below 0. So that means then that we have a relatively inaccurate forecast. It's based on the 12-month cycle, ignoring the last month. And so let's go back and see if we can change some of those and come up with a better model. So we right-click, Forecast Options. And now, instead of letting it be automatic, let us take and make a custom additive model. All right? Let's leave it like that, and then let's go back and change or take a look at our forecast trend. Click OK, right-click, Forecast, Describe Forecast. We go back to our models, and now you can see that every one of these numbers has decreased. Every single quality metric has decreased. What we've done is that we're relying more, let's go back to our summary, we are now relying more on the seasonality and less on the trend. So before, we had both the seasonality, we had just the trend built in and the other was automatic. Now we are looking at both the trend and the seasonality being higher. Also notice that this seasonal effect is much less now than it was before. Before it was negative 22 million, now it's negative 8 million. Even though it's still negative and that's not good, we're getting better. So this is a better model than the previous model. If we click Show Percentages, we can see that it's dropped from a negative 22% to a negative 18%, so that's good. All right. So I encourage you to click on the models, check them out, see which ones have the lowest error. Okay. All right, so now we're going to move over to the tab that says Describe. Here, we're going to use some descriptions to build each of those pieces in and see if we can come up with a solid model. So the first thing we've done is the order date has already been established for you. So we're going to go to Data. We're going to take the Measure Sales, drag it to the rows. And now it has established this forecast for you here. All right. We're going to take Order Priority, bring it to the rows. So take our Order Priority, bring it to the rows, and now you can see that each of them has built a different model: critical, high, low, and medium. Now we know that needs to be critical, high, medium, and low, so we can go ahead now and put that in. Right? So we'll go ahead and change that now so that we have critical, high, medium, and low priority shipping. Okay? We're also going to take Order Priority, drag it to the colors. So now that we have the different colors. Right? So critical is red, low priority is green. We're good. Now the part where it says double click the axis and make them independent, I've already done that for you here, so don't worry about that part. This is why each one of them is on a separate axis. Okay? The next thing we need to do is to right click, then Forecast. Okay? And we're going to describe our forecast. Let's check the box that says Show Values as Percentage. And now we can take a look at our models. For the critical, we can see that we have a fairly robust model here. So if we take a look, right, we can see that our critical is not increasing over time. Now, for those of you who are taking the predictive modeling class, what we see here is stationary data. The model is changing and fluctuating very little over time. We probably don't have much of a seasonal increase. As a matter of fact, when we look at the initial change from December 2015 to December 2016, we can see that it tells us that the percentage change is 0. There is no overall increasing trend in the critical shipping. That's good. Our critical shipping is not going up from 2015 to 2016. That's what we want to see. Okay? However, when we look at the seasonality, we can see that there is a change from one quarter to the next. That's to be expected. And so when we put all of that together, we get a good quality forecast, right? We get an okay quality forecast. When we look at others, like the high priority, we can see that our forecast here actually is increasing. So there is a non-stationary process here. The high priority is increasing over time. All right? So that's why we have an initial change of 34% from 2015 to 2016. All right? This is an okay model as well. For the medium priority, the yellow line, we can see that we have quite a bit of seasonality and we have a very high increasing trend. The seasonality is much more pronounced, of course, than the overall trend, and so that's why when we take a look at the seasonal effects for the medium priority, we can see that I said that backwards. We can see that we have a much more pronounced overall trend than we do a seasonal trend. So that's why the trend is at 100%, the seasonality at 0. And here we've switched to a good model because this one is the one that has the best forecast, or it has a very good forecast. We take a look at the low priority, we can see it's pretty flat, although there is an initial change of 18.2%. Let's take a look at the models here, right? And I'll let you pause for just a moment to answer the question, which of these 4 models has the better or best indication of the actual sum of sales? And so as we take a look at our quality metrics, we can see that the one with the lowest root mean squared error is the low priority sales. This is the one that has the highest accuracy according to the root mean squared error. It also has the highest accuracy or quality according to the mean absolute error. But when we look at the mean absolute standard error, we can see that the medium has the best, as well as when we look at the mean absolute probability error. Okay. So we put all of that together and you ask yourself, which is the better model? And the answer is it depends on what you're trying to do. Most forecasters in operations management will use the root mean squared error or the mean absolute error. When you're forecasting sales, it's generally the mean absolute standard error. And so the others can be put together in such a way that you can answer the question, which is the better, and you'll say according to whatever your manager has asked you to do. In this particular case, it's probably going to be the root mean squared error. Okay. Now, let's right-click one more time, Forecast, Describe Forecast, and we're going to click at the top where it says Models. Okay? Notice that the model that we're using for each one of them is different because we had checked the box that said Automatic. One of the things that you'll notice at the top is it says all forecasts were computed using exponential smoothing. Okay? So that means that Tableau is using what's called the Holt-Winter exponential smoothing model. I'm not going to get into the math in this video. If you're interested in knowing more about that, you can click the link below and it will take you to a website that will describe in detail what the Holt-Winter model looks like. All right, so let's come over here to the forecast fields, right? Again, we have created the order dates for you, and we want to take a look at some of the different fields and see how each of them can add to our model. So we're going to take the sum of profit, right? And we're going to double click that. Okay? So again, profit, double click, and it adds the sum of the profit. Now you can drag profits to the rows as well. Notice at the top you have this up arrow indicating that it has been forecasted. So we take drop profit and drag that to tooltip. And again, notice that the sum of the profit has been forecasted. We're going to pull down that little menu. We want to look at the forecast. And instead of actual and forecast, we want the precision. Okay? So now when we hover over this forecast, we're going to end up finding a forecast precision. In order to make that happen, we're going to click tooltip and we can edit that tooltip. All right? So we're going to come here to where it says forecast precision. We're going to select insert, precision of sum of profit. We click OK. Now when we hover over, we can see that we have a forecast precision of plus or minus 12 million. When we hover here, we have no forecast precision because these are the actual numbers. It's only when we're in the gray area that we have our forecast precision. We're also going to come to tooltip. Let's adjust that again. Okay. Before we do that, we have to add one layer. So we're going to take the sum of the profit, drag it to tooltip, pull this menu down, forecast results, and here we want the quality of the precision. Let's do this one more time where we take profit, tooltip, and this time we'll leave it as the actual and forecast. All right. So now when we hover over, we can see that we have to add the profit and we have to add the forecast quality. So we'll click again on tooltip for forecast quality. Because we have that in our tooltips now, we can insert quality of sum of profit. And for profitability, insert just sum of profit. We click OK, and now when we hover over our line, you can see that for January of 2016, our profits were approximately $34 million. Forecast quality is 48 out of 100, so it could be improved, of course. Precision is plus or minus $12 million. That is the difference between the upper confidence band and the lower confidence band. So the difference between here and here is approximately $12 million. So again, let's answer questions 5A and 5B. Why is it not showing for the actual? And that's because we've asked it to forecast the number. So the profit is showing, but the forecast quality and forecast precision are not. If we hover here, we see the profit is 45 million, but there is no forecast for us to actually use, right? And let's answer question 5B. How can we add to the quality of the forecast, right? And so the way we could do that is simply forecast options, and then we can change some of these things. Instead of automatic, we could add custom and make it additive for both. When we click OK, we can see now that our forecast quality is a little better, but not much. Right click, forecast options. Let's try multiplicative and see if we have any change. All right. So now we see the forecast model looks much different, but when we hover over it, the forecast quality is actually dropped quite a bit. And that's because our sales are not increasing exponentially. Rather, our sales are going to be increasing linearly. In other words, our compound annual growth rate is not an exponential, rather it's a linear trend. So we right-click, trend lines. Now we can see that we have this linear trend, right? So if we right-click, edit the trend line, and look at an exponential, it doesn't really change the model that much. All right, so the last thing we want to do, let's take this trend line out, right? And put our model back where it was. We're going to make this an additive model instead, and we'll leave everything else the way it was. Okay? So the last thing we want to do is pull this information out and actually put it back into a table. Now your instructions are over here on the crosstab field. So we're going to take the right-click the forecast field, duplicate as crosstab, and then where we see forecast field, we're going to right-click and rename this forecast fields crosstab rather than forecast fields 2. Okay. Now let's take a look over here, and we're going to take each of these in kind. All right. So for the sake of the video, I'm going to copy this and make my life a little bit easier. I'm going to paste it into a Word doc. So now I can pull it to the side and I have my options. So now we have our forecast fields crosstab, and just here we have these and these. So now we're going to swap the axes. And now you can see that it's given me January all the way up to 2016, and then these last are actual forecasts. Okay. So now we're going to click on the color. Excuse me. We're going to move our forecast indicators from the columns to color. Okay. So now instead of having separate columns for each, we're going to have columns and colors. And so you can see we have our different colors here. All right. Click colors, edit colors, and we're going to change the color of our estimate. Now you're like, okay, well, which one is the estimate, right? Each of these in kind, except for the actual profits in red, are going to change to a new color. So we're going to take each of these, we're going to leave this, we don't want red profit, so we're going to make that green. And each of these we're going to make a different color. So I'm going to go with the first one and just call them blue. Okay. And now you can see that our actual numbers are in green still, and our forecasted numbers are in blue. Okay. Let's remove the precision and the quality of the sum. Okay. So what you're left with is the lower prediction interval, the upper prediction interval, and the actual number here. Okay. Take our measure names, we'll put that back to the columns, and we get this funky looking thing here. Now, I want to invite you to think about why that actually happened. What we're trying to do here is create some sort of forecast model that is inaccurate. In other words, we need the date on the x-axis and the values on the y-axis. So if you get something that looks like this, you simply swap it back and you'll get that model instead. Okay? Let's switch it back. Take our measure values out. All right. Take the measure name, put that into the columns, and this is what we're left with. So now the green indicates that it's the actual number, and the blue indicates that it is the precision, or the upper precision or prediction interval and the lower prediction interval. We call this UPI and LPI for short. Okay? All right. Now, if we wanted to take this model and we were to swap the axis now, you can see that it simply takes it and moves it in each direction for us. Excuse me, it just simply flips it. The green stays the same. Now, we picked green and blue, right? Okay. And we could, if we wanted, edit those colors. We could make them whatever we want. We know that green and blue might not work for everybody, so let's pick a different color, right? Let's pick from our, from the Tableau 20, we have more colors to pick from. So for this particular one, we're going to pick purple, right? And then for these, we will pick some other color. I don't know, let's pick pink. Apply, and now we have our numbers here as well. Alright, so that concludes this video. We will take a look in future videos at how we can actually enhance this model a little bit and actually get a more precise or accurate forecast. Thanks and have a great day.